So today, of course, is about the topic of robust design, but I also see it as quite a connection point between several things. Firstly, it's a connection point between some of our young, most talented graduates who are just about to either do their master's thesis or are completing their master's thesis and about to go out to industry to connect with you subject matter experts who maybe have a few extra grey hairs on your heads. It's also a connection point between academia and industry. And I don't think in any discipline this is more important than engineering design. Industry is our test bed and our rig. And whatever we're coming up with in our labs, in our offices at DTU, if it's not tested to some degree in industry, it's borderline useless. So it only really makes progress when we're working together between academia and industry. And I really get the feeling that nowhere do we do this more strongly than in Denmark. I mean, if we look at the amount of subject matter experts in the room coming to this day, running student projects, running PhD projects with us, I'm immensely proud to be studying this topic here at the Technical University of Denmark. And finally, and it was alluded to a little bit in Niels Henrik's talk, this is the meeting point between analysis and synthesis. Now, our world in academia is becoming a lot more specialized. On one hand, we have the people going off doing very creative front-end conceptualization work, new business models, new product service systems, and of course these are incredibly, incredibly important. And then on the other side, we have growing capabilities, computational power on the analysis side. We can simulate virtually anything. And the middle ground connecting the two is somewhat lost. So we come up with a concept, put it into any embodiment, and then simulate the hell out of it until we get something that we can believe might work. But we can do a lot better than that. And that's where our discipline of robust design and mechanical design fits in. A very robust system I've got going here. So with that, welcome to Robust Design Day 2016. To give you a little bit of an introduction about the program today, we have the welcome address. Then we have a presentation from Dan Whitney, a professor at MIT, who is going to talk to us on the chain method for assemblies. Now, we've read quite a lot of Dan's work and we're extremely inspired by it. There are very few academics in the world in mechanical design who have such a deep knowledge of how to handle constraints when you're putting down your basic embodiment. And Dan is certainly one of those, perhaps the best in the world, so we're very privileged to have him here today. We then move on to the title of the talk is slightly wrong here on robust standardization of components, but I believe Janus from Valcon Design will be talking on robust design implementation. We then have a break and then a web presentation from Rolls-Royce on simulation and how it relates to verification and validation. We then move to the other end of the quality spectrum, over to perceived quality, and we have Emily Sundqvist from CEVT talking about perceived quality and what it means to the customer. Then we have a presentation from myself on the variation management framework. This is a new development at DTU, which we've operationalized in recent years. And then after the break, we'll be doing a workshop on this topic. We'll have another break and then a presentation from Bosch on Industry 4.0 from Ad Schiepers. And then finally, we have a presentation from Crispin Hales on forensic engineering and how variation may lead to some catastrophic failures. I've also seen Crispin present at many conferences, and I can tell you it's a joyous experience. Okay, so I would like to now give you a little bit of an update. Oh, I can see some of you getting very panicky. If you turn over your programs, at the bottom there is a Wi-Fi login and password. You go to the DTU network if you're desperate to get online. Okay. I'd like to thank very much our partners. It doesn't seem a very difficult choice to choose Valcon for the third year in a row as our industry sponsors, partly because we get Janus thrown in free as a keynote speaker, which is always very provocative and entertaining, which I'll look forward to. But this year we also have our media partners, EDA Design Innovation, EDA Process, and sponsored by the Design Society. We also have 3 software vendors who will be sat out in the dining area outside, so in the breaks, in the lunches. Feel free to go over to their stands and see their simulations. These are all chosen because they are very related to your topic, so you're not getting something that is irrelevant to you. These are genuinely interesting stands to go to. If you're not aware of them, JMP is probably the premier DOE and statistics package used in industry. Valka, would you like to stand up? So would you like a quick introduction to yourself?
Thanks, Tom. So I'm Volker. I'm from SaaS like Jump, our software I have to show out there. And as Tom said, Jump is used for DOE, but also for analytics and data modeling, including optimization, robust optimization simulation. So if you want to get a better idea, please stop by at the demo table for a short live demo or discussion.
Thank you. And then we also have the company Noesis, who have several different packages, but primarily the package called Optimus, which does have many different computer-aided engineering features, but one of them is robustness optimization. So is Jan in the room? Would you like to say hello?
Good morning, everyone. Optimus is a process integration and design optimization platform. So it allows our users to automate parallel simulation and perform robust optimization. And on top of that, Optimus is also an open platform, so you can easily integrate all your R&D work, such as algorithm and survey more.
Okay.
Yeah, feel free to come and I'll be happy to have a chat with you.
Thanks, Jan. And then finally, we have Sigmetrics, which is a kinematics package. It has two sides to it, the GD&T Advisor for GPS, as we may know it here in Europe, and CTOL Six Sigma, which is a kinematics package. So, Miroslav, could you quickly introduce yourself?
Shortly, what packages we are showing today. CTOL is based on exact constraint theory or kinematic design, integrated with several CAD packages. And directly in 3D CAD, we can do 3D tolerance analysis and optimization. And so the second package is called GD&T Advisor. It's like a kind of wizard for GPS tolerancing, when you can both quickly define the tolerances and verify against laws of physics and also ISO or ASME standards. And we are in the hall. If you want to talk to us or see the software, you're very welcome.
Great. So please go bring them a cup of coffee over and keep them company. Okay, so I'd like to give you now some little updates. We've been running this every year for the past 3 years, and I try to give a little update as I'm trying to make this part sort of the center of the community, so to keep you updated on the progress. In terms of the educational progress, the Robust Design course at DTU is really seeming to kick off. We get a lot of interest from the students. In the spring semester, we had 100 students going through the course. And quite a lot of those want to continue to do master's theses and projects. We've partnered up with Valcon Design in this case, and the top 15% in the exam are also awarded a 6 Theta diploma. So this is a picture of the 6 Theta graduates. There are quite a number of them here in this room. Perhaps maybe you want to raise your hand if you're looking for a master's thesis next semester. Oh, there you go, a few at the back there. And I can strongly recommend all of them. Right, okay. So to give a little bit of research progress on where we've been coming from, we submitted and had to the second review now the VMF framework, Variation Management Framework, in the Journal of Quality Engineering. And that is the basis of a lot of the work we're going to be doing in the workshop today. We've also had a paper published on looking at the principles behind robust design in the design area, and that was actually a paper written by Martin and myself before Martin had finished his PhD. Oh, thanks very much. One of those principles is manual adjustment, and in this case, it seems to be the right solution. We also had in the quality domain, in this top left quadrant, we had a paper on perceived quality, and also how to embed perceived quality and quality loss functions into our requirement specifications. Now, it seemed to us that a number of the requirement specifications being passed on to engineering design didn't actually have a great deal of quality information in them. We did a basic analysis of some of the design specifications looked at, and came up with an indicator to show that quite a lot of the quality information was missing, and therefore, before you start a project or before engineering is passed, we can basically put the specification on the scales and give some kind of idea of how much we know about the customer's expectations with regard to the quality of the different functions. We had a paper published in Quality Management and Business Excellence, or Total Quality Management and Business Excellence, on a process model for robust design. We then had what I consider to be a fundamental breakthrough in research in engineering design, where we had a model-based approach to assessing the importance of axiomatic design in terms of the coupling degree. Now, in axiomatic design, it's suggested that functions need to maintain functionally independent. In other words, they shouldn't be coupled to the same design parameters. But what we were able to do, showing through numerical simulation, was this isn't that or as important as we'd originally thought. It's more important that the that the coupling isn't a contradiction. In other words, that when two functions are coupled to a design parameter, that the functions aren't wanting the design parameter to move in opposite directions. And that's what really causes us the problem. So we found out the level of contradiction is the main driver when it comes to robustness. We also reviewed hundreds in fact, of different sensitivity and robustness metrics, and identified 38 unique sensitivity and robustness calculations, of which we produced 4 categories, which are published in the Journal of Mechanical Design. In the production domain, we've just had published a product maturation guide, which is linking the mold design and development in production right the way through to the functions. So instead of production companies just wanting to maintain dimensional tolerances, they can instead try and maintain functional performance of the product. And finally, we also had a whole bunch of other conference publications, so it's been quite a good year with regards to research output for us. Okay, I think we need a new solution for this. In terms of practical applicability, we're rolling out our robustness process, which has basically 3 overall stages. Firstly, to increase predictability with kinematics. Secondly, to decrease sensitivity. And thirdly, to allocate tolerances effectively. And once you've done those 3 stages, you get a robust performing product. At DTU, we mainly focus on these first 2 phases. There are many groups around the world doing effective tolerance allocation, so we focus on these early stages. And we've come up with a reasonably systematic process to guide both the students and engineers through the process to full robustness. Each of the yellow blocks on the board here basically represent a method. And out of these methods come a series of leading quantitative indicators. And these are all based around the lecture and training framework that we do for the Robust Design course. If you'd like some more information about what we're doing here at DTU with regards to robustness, there's a desk out there with all of our workshop and research and training material. Please feel free to go and help yourself and have a look at it. Okay, so I think that's the first part of my presentation over, apart from a quick thank you to so many of you for filling in the pre-survey for the workshop. I think well over the majority of you have already filled it in. If you haven't yet filled it in, you'd like to, it's less than 5 minutes. The link is on that board there. So with that, welcome to Robust Design Day 2016. Thanks.